Can everybody hear me? Yes, I'll take that as a yes. Hi, welcome. Thank you all for joining me this late. I hope you're still kind of awake so you can maybe listen to what I have to say. So today I would like to talk about consumer-driven contract tests and how you can use those to raise the confidence in deploying things on your platform without breaking things. Now, the story today might not be exactly a success story, but hopefully it'll be enough to maybe disrupt the way you do things in your organization and get you to think a little bit about how you do testing. So a little bit about myself. My name is Alon. I'm working at SoundCloud for the past 2.5 years in Berlin, Germany. I'm currently in the monetization team where we're taking care of all the payments, subscriptions, and ads systems in the company. I'm a backend engineer. I mostly work with Scala. I also do some Ruby, some also Go, even JavaScript if I need to. Yeah, and a little bit about SoundCloud. So it's a cloud full of sounds. We have around 135 million tracks on the platform with around 175 million users, unique users monthly. Our creators upload around 12 hours of audio every minute. In the engineering organization, we manage around 300 services, and these are managed by across around 50 teams. So, my agenda for today. I would like to talk about the history of my experience with how we used to test things on monolith. I will then talk about how I got to know what we do at SoundCloud when I joined the company. Then I will talk about contract tests, consumer-driven contract tests, what it means, what it is as a concept, and then how to use Pact to actually go ahead and implement contract tests and integrate those. And yeah, then we'll talk about some disadvantages, some caveats, things to notice when you decide to go down that rabbit hole. And hopefully we'll have some time for questions. So let's jump right into it. Yeah, so back in the good old days, we only had one service with one client. It was all in a single repository. It was deployable as a single unit. And as such, it was really easy to make changes to the API. If we wanted to deprecate some endpoint, it was easy to see if it's being used or not. There's just one client. It's built into that same system. If we wanted to change some payload format or anything like that, it was really easy. So we only had to talk to the client team, or maybe it was just us, the same team that was doing the same job. And yeah, that was all right. We had just one web client. But then we had to extend that and support more clients. So suddenly we had iOS and Android clients, and we had versioning, and we had like, it wasn't any guarantee that all users or all our iOS users will adopt the newest version. So we had to have like backward support. And so suddenly the code, the backend code became much more complex. We had a lot of if-else statements all over the code, if the request came from iOS or from Android or that sort of thing. And suddenly it was harder to deploy something without breaking at least one of those clients. So basically, if some change was needed and we did that, we just deployed it and we looked at the logs to see if anything breaks. And in order to cope with that, what we did is we added more manual QA. Our QA team grew, but that proved to be expensive, of course. It was slow, it was prone to human error, and it just doesn't scale. There's just so much that people can do in order to cover all of the edge cases and still have your code deployable with a small lead time. And we also added more end-to-end tests. For each case that we had, each client that we had. But those two they're flaky, they're slow, they rely on network connections, and they just create bottlenecks for deployments. So, fast forward to 2015, I joined SoundCloud. And the first thing I ran into is microservices. Just hands in the air, how many of you actually use microservices in your organization? All right, so yeah, so it's like the buzzword, and we've heard that across like the entire last 2 days, and I will talk about it as well. So microservices basically meant that each team had complete control over the entire flow. We have feature teams, so they do all the work front end to back end, and everything is domain specific. And so it's easy for teams to just experiment on different features and deploy things fast without much problems with other teams and such. So, and I was really lucky to join SoundCloud at a stage where microservices was not just a buzzword, but it was actually quite a supported platform. We had logging, telemetry, CI, CD, all that kind of stuff. So basically all that stuff is being taken care of, and we can just concentrate on actually developing the things that interest us. So as time went by, I noticed that we've had like a very familiar testing pyramid. This is what you want to have and not the ice cream cone. We have a lot of unit tests for each one of your units in each one of the services. We have some integration tests in each service when they interact with a database, with a messaging queue, or anything like that. And we have a little bit of end-to-end tests. And these are mostly managed by our client teams. So the iOS, Android, and web teams are taking care of those end-to-end tests. And I noticed that we do have outages. We deploy things to production and things break. And I decided to look into, like, to try and find some common reason for why these things happen. So I went ahead and I read some postmortems that we had. I basically ran through documentation for an entire year of postmortems. Postmortems are documents that we use to document any incident that happened in production so that we can basically research that and go back and see what we've done wrong and what can be improved so we can learn from our mistakes. And so I've noticed that around 20% of those outages occurred because of some broken API. Obviously, this smelled familiar, something similar that I've seen back in monolith days. And let me just quickly show you some quotes from those postmortem documents. These are real quotes. The first one, a lack of trust in the acceptance tests caused us to largely ignore the warnings they've generated. The second one, we couldn't figure out the impact of the broken acceptance tests and assumed the only problem was the tests themselves, rather than the underlying code. The third one, the commit went through as there weren't any tests for the serialization from the client to the backend. I'm sure some of this stuff sounds familiar to you. And so the first two quotes just stressed what I've told before about end-to-end tests and acceptance tests, that they're just too slow and flaky, and it's really hard to have confidence in them for a long period of time. The third one is exactly what I want to talk about today, what contract tests are there to, this gap that contract tests are going to fill for us. So here's what I think about unit tests, especially when it comes to services that have an API that they expose. Basically, these unit tests are kind of like you wake up in the morning, you go through your daily routine, you wash yourself, you get ready to go out, and just before you walk out that door, you look at yourself in the mirror and say, you look amazing, and then you start your day. But maybe what you really want to do is have someone that you trust, someone from your family, your friends, stand there beside that door, look at you, and just point out and say, you have something on your chin, or your shoes are untied. But of course, this person cannot be there every day, so maybe you'll ask them for some document with a checklist, things that you can look over every day and just say, oh, okay, my shoes are tied, I'm clean, everything's fine. But also you can ask them to come back every few months and update that list. Maybe their list of things have changed. Maybe they have another idea of what you should be looking like. Obviously, I'm not really suggesting you should do that. Let's go back to code. So this is how we currently write a unit test, and this is perfectly fine. So in this case, we have an endpoint called cake, and it returns lie. And of course, we have a test to cover that. So we try to call that endpoint, and we assert that the result is really lie. So if time goes by and for some reason something in our code changes and suddenly we return the wrong thing, our test will break and we'll basically not deploy that change and we're safe. And this is exactly what we want. But let's make this a little bit more complicated. Let's say that we are serializing our output, our payload, using some JSON library, JSON libfoo. And so now, when someone calls that endpoint, we take that current state variable and serialize it so that the output will be a JSON with current underscore state, so that's snake case, and the value will be lie. And so, of course, we don't want to repeat ourselves, so we just use the same library when we write our unit test. We'll just deserialize it with this JSON library. So when we call the cake endpoint, we deserialize the output and make sure that the result is lie, because that's what we care about. But what happens when we decide to upgrade that JSON library or change to another one, and we don't really care about that because we're declarative and we don't care about the implementation? So maybe that new library suddenly doesn't use snake case, it uses camel case. So suddenly the key will be current state with capital S. And our unit test that we've written, of course, it also upgrades with the same library version. So suddenly it passes, but we don't notice it. We go to production and boom, we break some client. So when we talk about contract tests, basically what we want to do is take some end-to-end tests or integration tests, some kind of test that has two different services, a consumer on one side and a provider on the other. The provider is the service that provides the API, and the consumer is the service that consumes this API. And we want to break that test into two different tests, unit tests, things that are localized, one on the consumer side and one on the provider side. And we will have some kind of a document in the middle that will be the glue of those two tests. And this document in the middle will be our contract. So if I go back to that example I've shown before, on the consumer side, we're going to say, okay, I'm going to request, to make a request to that endpoint cake. I expect a JSON response with the key current underscore state. So far, this is just what my expectation from that service, from the provider service. And now I can go ahead and write my test. And my test will be that I'm making an assertion that I'm actually deserializing the response correctly and looking at the status code and looking at the payload and so on. So with the first part is the expectation, and the second one is the actual test on the consumer side. On the provider side, what we do is that we replay those expectations that were defined by the consumer and say, given a request to the endpoint cake, I'm returning something, and that something should be a JSON with the value, the key current underscore state, because this is what the consumer expects. So we make this verification on the provider side. So let's talk about Pact. Pact is a family of frameworks that were built specifically for the task of allowing you to implement contract tests. And they support mostly HTTP and JSON as the underlying format. In version 3, they also support messaging queues as well, although I don't have much experience with it. So just if you have any questions about it, I'll be happy to try and talk to you about this, but I don't guarantee any answers. There is implementation in many common languages like Java, Scala, Go, Ruby, .NET, Swift, etc. So, for example, the Pact JVM implementation, you can take it and use it to implement contract tests in Java, Scala, but also you can take it to implement the consumer-side test in your Android app, if you want. And the idea is that, as I said before, tests run locally, and there is no external dependency on other services in your environment. Now, yeah, let's take a look at how it looks. So first, we define the consumer expectations. On the consumer side, we record those HTTP requests that the consumer does and the responses that it expects. And this set of expectation are recorded into a PACT file. This PACT file is kind of a JSON format, and we'll take a look at an example later. And then once we have that, we can asynchronously run a verification phase on the provider side. So the PACT framework will allow us to run a PACT verify command, which will basically replay those HTTP requests against our provider and verify that the HTTP response matches what is expected. So what I would like to do now is walk you through an example of how to take an existing unit test on your consumer that you currently uses mocks or test doubles and replace those with the PACT framework. And I'm going to be using PACT JVM and Scala for this example. So let's take a look. We have a service. Our provider service will be the likes service. It's a service that allows users to like a track. And this service has a consumer, some service that uses it to basically relay requests from users to like tracks. And in this case, what I have is an integration with the get endpoint, the get likes endpoint on that likes service. So in this case, we see our likes client. This is the code on the consumer side that has this method, get likes for. It gets a user ID, and it returns a list of likes. And so it uses some HTTP client to make a GET request to likes / the user ID, and then it looks at a response. So if the response is has an OK status 200, it'll take that body of the response, the payload, and we'll just parse it. For this example, we don't really care about the implementation, but basically it'll take that JSON code, JSON payload, and parse it into a list of likes. If we get a 404 not found status, we just return an empty list of likes. And if we get a status that we don't know about, we just throw an exception. Not the best practice, but for example, it's good enough. So let's take a look at how currently we have a unit test set up for this method. So first of all, what we do is we're using some mocking framework to mock that HTTP client. And then we use that mock to initialize a likes client, which is our code. And then we have some stubs put in place. So we say, if the HTTP client gets a request to get likes / 1,000, then we'll return a 200 with some JSON fixture. And if there's a request to get likes / 2,000 for user 2,000, then we'll return a 404 not found without any payload. And then we can go ahead and make our assertions. For this example, we'll just assert that we have a list of 2 likes for the first test and a list of 0 likes for the second test. So far, so good. Let's see how we take this and shift it into the PACT domain. So in PACT JVM specifically, we have something that is called a PACT fragment. And let's take a look at what we have here inside. So first of all, we are defining the name of our consumer, which is my consumer in this case, and the provider, which is likes. We then go ahead and define the list of interactions that the consumer expects from the provider. This is what will be then recorded into that PACT JSON file that I mentioned before. So in this list, we have the first interaction, and notice how basically it's kind of like that stub that we've created before for the HTTP client. If we get a request for likes / 1,000, then we return a 200 with a list of likes. So let's see what we have here. We have, we have state, given that user 1,000 has liked 2 tracks. When we do a request to fetch a list of likes, then the request that the consumer will make is a request to a get endpoint, with a get method to the path likes / 1,000, and the response that the consumer expects is status 200 with that JSON fixture in the body. And for the second interaction, notice how basically it's parallel to that other example we made with where we stubbed the HTTP client to say if we get a request to likes / 2,000, we'll return a 404. So again, user 2,000 has liked no tracks. When we fetch a list of likes and we make that request, we'll get a status 404. I will go back to talk about that state thing. Don't worry about it. I will make that clear later on. So now let's see how our test looks like, given that pack fragment that we've defined. So now notice how instead of mocking that HTTP client or creating a test double for it, we're actually initializing a new HTTP client with something called providerconfig.url. This is something that the Pact JVM framework gives me when I basically initialize it. What the Pact framework does is it actually initializes, it starts a HTTP server that will record all of my interactions. So that HTTP server is now available in this URL, and we can use that to initialize our HTTP client. And now we can just go ahead and make our assertions. When we call get likes for 1,000, we expect the list of likes to be 2. When we make that call with user 2,000, we expect the number of likes to be 0. So once we run those tests, this is the side effect of running them. Except for making the assertions, we get this file. So we can see this is very similar to that pack fragment that we've seen before. This JSON file contains the provider name and consumer name, and it contains the list of interactions. Given this these states, user 1,000 liked 2 tracks, user 2,000 liked no tracks, we have this description, fetching a list of likes, we have the requests, and we have the responses. Those question marks are basically that big blob of JSON that I didn't want to put in the slide. Just imagine there's something there. So, on the provider side, basically we're done. On the consumer side, we're done. We have a packed file, we have tests running locally, and now we can basically share that file with the provider. And we'll talk about how to share that file in a minute. But what do we do on the provider side with that file? So what we want to do is basically collect all of those files from all of our consumers, because probably we'll have more than one, and we want to run their verification phase. And again, we'll do that using whatever Pact framework that we choose to use on the provider side. And it's really important to make sure that our provider environment is isolated. So if we have any dependencies on a database or something like that, we'll probably want to Dockerize it or create an in-memory database, something similar to what we've seen in the Wix talk yesterday about test kits. And we also want to create test doubles for any upstream services that this provider service depends on, because we don't want to end up in this situation where we have, again, flaky tests where we depend on information that may or may not exist down the road. So let's go back to talk about, those provider states. Basically, as I said, we want to make sure that we're isolated, and so we need a way for the consumer to kind of do a setup of some kind of environment so that when they run those requests, they actually get data back. And these are what those provider states provide us with. These statements in version 2 of Pact basically are just plain strings. these are things that you're going to talk about, like there's going to be some communication between the provider team and the consumer team, and you'll agree on some strings that when the consumer sets those and passes them to the provider, the provider can use those to set up some kind of a state that will be there once the request comes in. And let's look at how this looks like on the provider side. So let's say that we have our likes app, and it uses the likes database. And so when I run my Pact verify phase on the provider side, the Pact framework will, first of all, send me this state request saying, please make sure that user 1000 has liked 2 tracks. And probably what I'm going to do is just make some inserts for that user into the database. And the next step will be that the Pact framework will actually send me that HTTP request for get likes /1000. And now I can safely know that I will respond with a 200 with that payload because we've set this up before. And the same idea goes with the second case where we have a user that hasn't liked any tracks, and so we probably will not do anything or delete anything that might have been there before for that user. So let's talk about sharing those Pact files. So maybe when you first start playing around with those frameworks, and this was actually the case at SoundCloud, we basically just put those files inside the provider repository and committed them, just so we have a chance to play around with this and yeah, just create some MVP. But of course, this is not scalable. You want to support versioning and all that. So the Pact world basically supplies us with something called the Pact Broker, which is kind of an artifact manager for Pact files. And so this allows you to, this is like a fully fledged web service that allows you to share Pact files between projects, and it has a very useful UI, and we'll take a look at some screenshots. And also it allows you to do tagging of Pact files and also versioning. And we'll see how it plays into our CI later on. So that Pact Broker, this is the main screen. What you can see here is relationships between different services on your platform. You can see which services have defined contracts to which other services. And when you click through one of those, what you get is a nice screen where you can see the interactions between that consumer and the provider. There's also a network view where you can see basically a kind of a dependency graph. An incomplete one because probably not all your services have contract tests written, so this is a kind of a dependency graph only for those services who have defined their contracts. So how does all this look on our CI pipeline? So on the consumer pipeline, what we do is once a change is pushed, we generate all the consumer contracts by running all the unit tests. So we get all those new Pact files versioned. And once we deploy the consumer to production, we then upload all those packs to the Pact Broker and tag them with production tag. And this allows our provider to make sure that it's always running against the production version of the Pact contracts that were defined against it. So on the provider pipeline, when a change is pushed, we verify all the production tag pacts, and only once those pass, we deploy. So what can go wrong, or what to look out for? So first of all, communication is key. The fact that you have some system that you can use now doesn't mean that it makes communication obsolete. There's still going to be talks between the teams to understand how to build that API, what goes in there, what doesn't. And basically what's nice about Pact or contract tests in general is that it allows you to put those agreements into written JSONs. So basically you have a documentation of those agreements. But it doesn't mean that you can just drop communication at all. Second thing is that basically we're introducing new moving parts, and this can be a problem. Depends on how big your organization is or how it adapts to new changes. We are introducing more frameworks to integrate into our different systems. If you have different technology stacks, then you'll have different Pact frameworks to integrate with. And we are also adding more steps into our continuous integration. On the other hand, we must remember that hopefully this will help us get rid of some end-to-end tests that are bugging us a lot of times. So maybe that can help us save time there and also avoid some mistakes in production. There's also some learning curve when we introduce this new framework. I can certainly say that it took me about a month to get Pact.jvm to work the way I wanted it to be. I had to also fix some bugs there and all that, and this leads me to the next point, which is that those frameworks are kind of work in progress. There's still a lot of things, features and bugs to be resolved, depending on which version, which framework you're going to use. So there are some that are more mature. For example, the Ruby one and the Pact.jvm one are very mature. But if we look at the Swift, for example, I think it's still kind of taking its baby steps. So it's very important to look at how mature that framework is. My next point is that the provider side setup can be time consuming. So I talked about how we want to make sure that our provider is isolated. So we want to create test doubles. We want to set up Docker with database and all that. So and we want to support all the different states that will be coming in from different consumers. So this can be a little time consuming, but it's mostly just a one-time thing to be done. It's not something that you have to continuously support and update too much. Once you have it in place, it's fairly easy to tweak it a little bit. So yeah, but this is definitely something to take into account. There's also the problem of how to automate the consumer-driven verification. So let's say that there is some agreement between the two teams to actually make a change to an existing API, but each team works through their backlog in a different pace. So maybe the consumer team will be finished with their change, basically adapting to that new API quicker than the provider, and they need to know if they can go to production or not. Basically, we want to make sure that when they push their change into their CI, we don't allow them to go to production without the provider having their change already in production to support that. So this problem is not an easy one, and it still relies a lot on communication between the teams. And it's something that is that can be resolved, but it's not an easy one. And also, adoption is essential. So, and this is the problem that I'm facing at SoundCloud, or we are facing at SoundCloud. If you have just two teams working with contract tests, it doesn't help you a lot, the entire organization. It just means that you have two teams doing something that they like to do, and it's not something that really helps the entire organization. So we try to hold workshops and have some kind of a group of people that advocate using that and like have the skills to help teams integrate with contract testing. But definitely it's still a challenge. So let's do a recap. We have consumers which write contract tests. These contract tests generate Pact files. The Pact files are published to our broker. And then we have the providers verifying those Pacts. And we have to remember that those providers are also consumers, so they themselves also write contract tests to other services that are their provider. And this is it. We have some time for questions, I believe, like 10 minutes. right? Thank you very much.
Hi. Yes. Hi. Hi. Thank you for your presentation, and I have a question around Pact. So, in your example, you show us that when you write in contract test, you're using and stub only GET requests. But is there any possibility to do something like mocking when your consumer test need to post some data into your provider, and you need to verify that this data is okay, it's not corrupted, and so you have response requests from post side, and this kind of integration is also okay.
So are you talking about the case where we're using mocks, like before we add contract tests? Or, I'm sorry, can you...
So does Pact allows you to test and hold post request and do assertion in provider side. So in your case, you do GET, then Pact returns the same data, some stubs, and you do assertion in the consumer side.
Yes. So,
but is there a possibility to do asserts in the provider side?
So, okay, it's a good question. It's very important to remember that contract tests are not there for consumers to verify that the provider has their business logic correctly implemented. They're there only to make sure that the API is done correctly. Okay, and so it's not there to be used by providers to check their business logic. This is what unit tests are for, basically. Mm-hmm. Yeah. Does this answer your question?
Yeah, yes. So you replace all this kind of logic that your application as a consumer sends to provider is business logic and unit testing in the consumer side.
So I'm saying that the consumer should not be testing the provider's logic. There shouldn't be a test in the consumer that says if I send a request to the provider, then later I see in the database something. You know, there should be like a good limitation, like the good separation of concerns here.
Okay, maybe another example. So what if provider API, you should post some data into provider side, and then you don't care what will happen. But what you do care is what kind of data you will post to this provider. So it's also kind of contract test. So, but contract from your client side or consumer side to this provider. So what kind of data are sending to the provider during some, I don't know, some flow. So in GET, when you receive data from provider, everything is clear.
Okay.
But when
so
you
about
send,
in post.
Opposite side, yes.
So basically, again, it doesn't matter what method we're testing. I think basically, even if you're testing a post, a delete, a put, doesn't matter. You want to make sure that when you do that post, you get back the status code that you're looking for, or the payload that you're looking for. You shouldn't be testing that the provider does its job.
Okay.
Does that make sense?
Yes. Yes.
Okay.
Thank
you. Thank you. And how does the stuff work when provider is consumer? When provider uses some service and his response depends on some service.
Right. So that's what I was talking about before, where you want to make sure that your provider is completely isolated. Where is that? Yes. You want to make sure that your provider is isolated when it's running those pact verification against its own consumers. So if it depends on other services, you want to create test doubles for those. You want to make sure that you're not really using those actual services. There are plenty of tools out there, depending on which language you're using, to allow that to happen. And definitely it adds more work for the setup. Indeed, yeah. Does this make sense?
Thank you. As far as I understood, you can use this approach only because your client's team, they basically were part of SoundCloud. And this approach cannot be used if you have some consumer who relies on your API, right?
Right. So we have a public API, and we have third parties that integrate with us. There's no way to implement this kind of thing on their end. What we can do is basically build our own kind of a like sample client that uses that public API of ours, and make sure that this internally implements contract tests based on some assumptions that we're making on how our external clients will be using. But this definitely kind of goes back to that kind of unit test where we don't really know how we look like before we step out of the house, right? So yeah, definitely this approach is there to allow you to implement tests internally, and against external clients doesn't work that well.
And related question, have you thought or considered, have you thought about such things as, you probably heard about GraphQL, right?
Yeah.
So it basically a little bit addresses one of this problem, that you can, every client can fetch the data they need. So have you thought about approaches like this?
Yeah, it's a good question. I would love to talk to you afterwards if you have experience with this. Like, there's been talks about, there's been some talks about GraphQL, the company. There are other concerns that that introducing GraphQL has with them, but yeah, I don't have a clear answer for that. Like, it might be resolving those issues that we're talking about here, but yeah, I don't have a clear answer. I'm sorry. Anyone else? Okay, so thank you very much. Enjoy the rest of your time in Kiev.